Welcome to Introduction to Functions. The best way to use these videos is to take notes while I'm teaching, pause the video often to get the notes down, and every time the video arrives at a you try problem, pause and attempt the problems. The solutions will be shown along with work. These are the items we'll be covering in this video. We'll start with visual representations of relations. So items that are not necessarily functions, we use the word relation. So we've got mapping diagrams and we've got tables. So what makes something a function? To be a function, each input has exactly one output. Each input has exactly one output. Domain are the x values, or the set of all the inputs. And range is the y values, the set of all the outputs. So another way to think of a function is each x has exactly one y. We'll go into that a little more deeper in a minute. So identify the domain and range from the table. All right, so input, another word for input is x and output is y. When we are identifying domain and range, we need to list it from small to big and no repeats. Okay, so no repeats, there we go. All right, so our domain would be 0, 1, 2, and 4. Domain is our x values. The range is our y values. And now notice we need it to go from small to big. So 1, 2, no repeats, 5. That is the domain and range of this function. Example 2 is a mapping diagram. Identify the domain and the range of the function. So these are our inputs, or our x's, and these are our y's, or our outputs. So, domain, small to big, no repeats, 1, 2, 3. And our range is our outputs, small to big, -3, 4, and 7. Create a mapping diagram given the table. Now these may seem pretty straightforward, but it's really helpful to take a look at how I map them out. This will help us when we try to figure out functions later. Okay, great. So I'm going to write input, sorry about that, input and output. We could also say x and y. Now don't just go listing them. We want to actually map the input to the output. So, and we don't want any repeats either. So we're going to input the 0 maps to 5. Notice how I did that. The input 1 maps to 2. The input 2 also maps to 2. I don't need to write it again. And the input 4 maps to the output 1. And that's how you create a mapping diagram. Create a mapping diagram given the set of ordered pairs. So maybe you need a reminder that these are all x and y. So our mapping diagram, x, y, input, output. So our map goes from 0 to 2, 4 to 5, 1 to 3. Now I'm at 1 again. I don't need to write it again. So 1 to 5. You try the following examples. Press play when you're ready to see my solutions and my work. Okay, now we're going to determine if if a relation is a function given inputs and outputs. And now the way that I like to think about it is a little bit strange. So to determine if something is a function, given a table, ordered pairs, or mapping diagram, I like to think about frogs and lily pads. And the frogs are our x's, and they're jumping to our lily pads, or our y's. Now, the most important thing I want you to remember is that we don't want to kill any frogs. That seems obvious. It doesn't seem like we should say that even in a math class, but we don't want to kill any frogs. And how frogs can die is when they try and jump to more than one lily pad at a time, their legs split in half and, well, you get the idea. So I just want you guys to watch the next slide, okay? So don't actually write any of this down, just watch the next video. All right, so this frog is going to jump to this lily pad, this frog is going to jump to this lily pad, and this frog is going to jump to that lily pad. Everybody survived. This is a function. Now, something that can look a little different. This frog jumps to this lily pad, this frog jumps to this lily pad, and this one jumps to that as well. Now, did any of the frogs jump to more than one location at a time? No. This is actually a frog party, and that is totally fine. It's when the frogs try to go to more than one place at a time. So this is a function. Don't write frog party, write the official math vocabulary of function. All right, let's take a look at another one. So this frog jumps here, this frog jumps here, and also here. Is this a function? No, this poor little guy did not get to make it. This is not a function. We'll try a couple more. This guy's going here, so is that guy, and he's going over there. Is this a function? Yes, because they're having a frog party, totally fine. The issue is when more than one tries to jump, or one tries to jump to more than one location. And last example, is this a function? Not a function. Good. Because this frog isn't going to make it. Awesome. So you might say, like, I don't understand how that's related to inputs and outputs, but all we're going to do is think of the x and the y. So determine if a relation is a function. When we're given a table, we're going to make a mapping diagram and see if any frogs or x's have been hurt. So we'll map x and y. Remember, don't just list them out. You want to see the frogs jumping. So 3 maps to 1. We're all good. 6 maps to 2. 9 also maps to 2. Frog party, totally fine. 12 also maps to 1. Is that a function? Yes, there are a couple frog parties, but that's okay. Let's try this next one. We've got our inputs and our outputs. Map 2 to 0. We've got frog 2 again, mapping to 1. You might already realize that this is not going to work. This is the problem here. This is not a function. We can do the same things with ordered pairs. If we want to determine if it's a relation, if a relation is a function, we do the frogs and lily pads, and then we determine the domain and range because that's what the question asks. So let's take a look here. So we've got frog 0 to 1, frog 0 to 2, frog 0 to 3. This is not a function, but it still wants the domain and range. The domain is number 0, and the range is 1, 2, 3. Let's take a look over here. We've got frog 1 to 3, 2 to 4, 3 to 7, and 4 back up to 3. This is a function. Let's take a look at our domain, or all of our x values. 1, 2, 3, 4. And our range, from small to big, we've got 3, 4, and 7. You try on the next page. Press play when you're ready to see the solutions. Now, what if we're given a graph? How can we determine if a relation is a function? I don't want to write out all the points that have a graph and then turn them into frogs and lily pads. So we use what's called the vertical line test. Given a graph, we use a vertical line, or several vertical lines, to determine if it is a function or not. A relation is a function if there are no vertical lines that intersect the graph at more than one point. We're still kind of thinking of frogs and lily pads. We don't want to hit in more than one point, or we don't want to be in more than one place at a time. So here's an example. This is a function because no matter how many vertical lines I draw, I'm only hitting at one place. These are terrible vertical lines. But here, we're actually at 3 places at one time, so this is not a function. Let's take a look here. Determine if the following graphs are functions. So if a graph is a function, it'll pass the vertical line test. So pass, 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 pass. This is a function. Now, can you find a spot on this graph where it hits more than once? I can find several where it's hitting at more than one spot. So this is not a function. And then here, I'm going to draw a bunch of vertical lines, and it passes everywhere, so this is a function. You try the next slide and press play when you're ready to see my answers. And finally, we're just going to briefly introduce function notation. Once we know something is a function, we can actually rename it using this function notation here. It looks like f parenthesis x parenthesis, but we actually read that as f of x. And f is simply the name of the function. Could be f, g, p. X is our input. And whatever's right here, this is the function itself. So sometimes you're going to see if an equation is a function, they'll use f of x equals instead of y equals so that they can show that this does pass the vertical line test, that this is a function. So y equals f of x defines a function named f. This is read as y is a function of x. The letter x represents the input and the letter y or f of x represents the output value. And this concludes our introduction to functions.